I wanted to talk to you about the basic steps for solving an absolute value equation. So I really like the lesson that we just finished. I think it's good. It gives some good ideas, but it doesn't actually explain how to do it. So that's what this video is. It's just, how do you do it? How do I solve an absolute value equation? How do I solve an absolute value inequality? So we're going to talk about the look inside for just a minute. We know this stuff is either 20 or it's negative 20. Because when I take the absolute value of it, I get 20. So the stuff is either 20 or negative 20. So this actually implies two separate equations. So what I do is I look at the stuff and I make it 20 or negative 20. Now there's another way to do this that's a little trickier where you make the stuff negative or positive, but I find that to be, it's what happens with the inequalities, and it's what makes those more understandable. But I find it to be a little bit irritating, and but it does work in the long run better, but it's a little bit tricky. So let's just go with this. We got our stuff as negative or positive. So we solve, we get 3x equals 15 and x equals 5. And then over here we get 3x equals, excuse me, that should still be positive, negative 25, and x equals negative 25 over 3. And so those are my two answers. Now this one cannot be equated to the whole Duncan, that's the wrong name, Emerson, and I don't remember the main kid's name, Henry, Emerson and Henry's bike riding situation. It doesn't equate to that. It doesn't equate to Amanda and Emerson and Henry, but that's not the point. The point is, this is how you do it. You make the stuff positive equal to positive or negative of whatever's on the other side. Now, that can get a little tricky if you have, say, 2 absolute value 5x plus 7 minus 8 equals 15. I don't care what happens. So like this. And so when I get something like this, it's a trickier situation. One, you can just pretend they're parentheses and just go for it, but that will only get you one of the right answers. Absolute value makes everything a little bit funky. So what you have to kind of do is treat the absolute value like of the variable and isolate it. So we're going to go ahead and add 8 to both sides. We've got 2 absolute value, 5x plus 7, close absolute value, equals 23. Sorry about that. We're going to divide by 2. I'm actually going to change this number so we get a nicer result here. So, excuse me, just to clean it up a little bit. It'll get ugly in a minute, but I won't want it to be ugly yet. So, you know, sometimes when you're making up problems on the slide, weird things happen. So, whatever. That's what, you know, this one came out of my head. Comes funny. Anyway, so then we're going to divide both sides by 2. So then the absolute value is isolated, and then I can go into the motions of what I was doing before. So the stuff is 12, or the stuff is negative 12, and solve those. And these are both going to be fractions because I didn't think it through. That's okay. Minus 7 minus 7, 5x equals 12 minus 7, 5. I guess maybe, no, 12 minus 7, yeah, 5. Well, hey, that one works out. And so x is 1. Hey, I guess I got lucky. This one we subtract 7, and we get 5x equals negative 19, and x equals negative 19 over 5. I found often, and maybe it's just the way I make up problems, that one of them's a nice number and the other one's not. It just depends. Sometimes they're all both wrong. They're hard to make up, so they work out clean. So there you go. At least for me. Maybe somebody else is better at it than me. It's possible. So that's absolute value equations. They're very straightforward. They're weird because they're two pieces. So if you want to look at just going to graph absolute value for you on Desmos really fast. So, so if I graph an absolute value equation here on Desmos, I find that, so there's two ways to get an absolute value equation. One is ABS, and let me move my face for a second. One is ABS, and then it knows that you mean absolute value of x Ta-da. The other way is to use your keyboard, because if you don't remember that, there's the absolute value symbol. So absolute value of x. Ta-da. So that's what an absolute value looks like. And what it looks like is two lines joined together to make this pretty graph. And that's what it is. Absolute value is what we call a piecewise function, meaning that you can define it in two pieces. We will spend some more time with that type of equation, I believe, this year. So, and if not, if we don't, you'll absolutely spend time with it in Math 3. So the piecewise function is really, really important that you look at the two pieces, because this is really y equals negative x until when x is less than 0, right? And y equals x when x is greater than or equal to, and it doesn't matter where the equal goes, but equal to 0. And so now I have the exact same thing that I had before. So it's two pieces solved together. So we have to kind of keep that in mind, is there's always these two things. So we say, hey, when is it 4? Then I get two answers, negative 4 and positive 4. And so when we're solving, we're looking for those two answers. So that's just an important piece. I'm going to drag my face back across the board, see where I put it. Oh, wait, did I close my face? I don't know. Anyway. Apparently I closed my face. That's cool. I don't need to be on screen. Let's take a look at an absolute value inequality then. So we know that we have this, and we add 2 to both sides, and x is less than 5. The part that gets tricky is when we set up the other one, because really it was this. This is really becoming that. And so that's the part that's weird. So if I did that, then I would get this. And so when you set up the negative case with absolute values, you have to remember to switch the inequality symbol. And we'll get into that in just a minute. So x is then greater than negative 1. And so on my number line, I have negative 1, I have 5. Those are both supposed to be open circles. And so I need x to be smaller than 5 and bigger than 1. And so then I get the numbers in between, because that's when I'm less than 3 spaces away from 2 in this case. Okay. And so that's really one of those kind of tricky things of what's happening there. So there I am. So let me just kind of talk to you about what happens with absolute value inequalities, because they are harder than equations. Two things. So you have, I'm going to call this Q, and your symbol. So you've got the two symbols. So we've got this one and a number. We'll call it number. Okay, so let's say I have this. So what we know is that this becomes, so we need to be less than away from a point. Less than number away from center, wherever center is. That doesn't make a lot of sense. But if we go back to the Henry idea, wherever Henry is, Henry's house was the center for a while, and then sometimes Henry himself was the center. So we had, I'm less than 2 miles away from you. What does that mean? Well, that means I can be anywhere from 1 foot away from you to 2 miles away, but I have to be close to you. So I have to be inside. So when we have a less than, we always end up with between. Okay, so when we have less than, absolute values all isolated, numbers on the other side, we always end up with between. When we have greater than, we always end up with outside. So let me show you what I mean. We're going to do a couple practices. And then how is this different as there? So if we look at this one, I have this situation here. So I have greater. So I need to be more than 1 space away, right? I need to be more than 1 space away. So when I solve my inequality, x is greater than negative 1. And then when I do it again, x plus 2 is less than negative 1 when I switch. So my second one is a switch. That's the hard part to remember. So what I just do is I kind of do it, I just find the two numbers, because it doesn't matter but I know that it goes out or farther away. So greater goes out. And so that's kind of an important thing. So these are the other problems. Let me just do this less than one. So we've got, no, here's something important. The absolute value is less than a negative number. And since the absolute value is always positive, it can never be less than a negative number. So I don't want to do that example. Let's do 3x minus 11 is less than 2. Okay, let's do that instead. So there are some no solution ones, so just kind of keep that in mind. But anyway, 3x minus 11, I just kind of go with 2, and then I do my other one, 3x minus 11 and negative 2. So I really just treat it like it's an equation. And so I add 11 to negative 2. I get 3x is equal to 9. I add 11 to positive 2. I get 3x is 13. And so x is 3 or 13 over 3. And so when I'm solving it, I'm going to put 13 over 3 is 4.33333. So 3 and 13 over 3. So that's the part you need to remember is which one is it. I've got my open circles, and it's less than spaces away, which means it's in between. And so my answer becomes x is in between 3 and 13/3. And so there's my answer. Now you can leave your answer as 2 inequalities. That's fine. So you would say x is bigger than 3, x is smaller than 13/3. And then you say and, because there. Whereas this one you would say between these two answers, or. Now B, an absolute value of something is bigger than 0, more than 0 spaces away. That's every single number in the world. It will always be more than 0 spaces away. So kind of keep those things in mind. There's some weird things there. So this one is every real number will work. It doesn't matter. So just that's kind of the idea. So again, to sum up, inequalities. Less than. These two symbols, less than and less than are equal to. Answers are between. Greater or greater than or equal to, answers are outside. This one is an and. Both have to be true. This one is an or. They cannot be true together. So there's your basic sum up, and I don't know if this made it anything better or if it made it all worse. We're going to be doing there's your homework and probably some Khan Academy to go with this to kind of round us out. So have a great time, and I will see you in class next week.